हेलो एवरीवन, वेलकम टू अजीत कोड्स। तो आज का प्रॉब्लम है मिनिमम डिलीशंस टू मेक कैरेक्टर फ्रीक्वेंसीज यूनिक। सो वी हैव टू मेक कैरेक्टर फ्रीक्वेंसीज यूनिक. A string S is called good if there are no two different characters in S that have the same frequency. Given a string S, return the minimum number of characters you need to delete to make S good. The frequency of a character is the number of times it appears in the string. For example, in the string AAB, the frequency of A is 2 and the frequency of B is 1. So in example 1, we can see we have given S equals AAB. Here the frequency of A is 2 and frequency of B is 1. And both the frequencies are unique. So we can say that yes, this is already a good string and we don't need to make any deletions. So the number of deletions here are 0. Example 2, we see we have got a string AAA BBB CC. So here the frequency of A is 3, frequency of B is also 3 and the frequency of C is 2. So we can only reduce the frequency, we can't increase it. So we see one, first we see A. So A has got unique. So A is the first frequency. So we say yes, we got a character with 3 frequency. Next we see B. When we see B, we see that a frequency of 3 already exists. So we try reducing B to 2. Then we see, do we have seen a frequency 2? No, we haven't seen. So we add it in our list. Next, when we come to C, we see that C has got a frequency of 2, but we have already seen a frequency of 2. So what we can do? We can reduce it to 1. And now, if we see, we haven't seen this frequency. So it will be 1 added to the, let's call it a scene, set of scenes, set of scene. And this is our, we can say map, frequency map. So we can either use map or simple arrays, because here all the given in the constraints S contains only lowercase English letters. So we can make an array of 26 size and store them, the frequencies. Also, when we look at example C, here we find that the frequency of A is how much? 1, 2, 3. Frequency of A is 3. Frequency of B is 2. Frequency of C is also 2. Frequency of E is 1. So initially our scene set is empty. When first we come to A, we see that it has got a frequency of 3. So we add 3 in our set, and also we need to keep one point. We will use a variable answer, and when we are decreasing, we will increase our answer by 1. So here we have decreased it twice, so our answer will become 2. That's the number of characters we need to delete to make it a good string. When we come to B, it's also the first time we are seeing 2, so we'll add it 2. When we come to C, we see that 2 is already present in scene, so we will reduce it by 1 and it will become 1. And also our answer will become, now answer will become 1, and we will add it in our scene. When we come to E, we see that it has got a frequency of 1, but 1 is already present, so we will reduce it to 0, and we can add 0 and our answer will become 2. So this is to be noted that Note that we only care about characters that are still in the string at the end. That is, frequency of 0 is ignored. This is important because if this was not the case, then and suppose our string was A, B, C, then the frequency of everyone is 1 and B can maximum go to 0 frequency, C can also go to 0 frequency, and these would have the same frequency at the end. But we don't need to consider them, so we only need to consider the strings that are already present in the string, and in this case our answer will be 2. So now let's see how to code it. For the coding is the concept is very clear. We first need to get the frequency of each and every character. Then we will start from the we can start, it doesn't matter on which order we start. We will simply start traversing the frequency map. Then what we'll do, we will keep track of what the frequency we have seen using a set. Next, we keep on moving and will keep on decreasing if the frequency is already seen. Now let's see how to code it. First we require is a frequency map. So for this we will declare a vector int of, let's call it frequency, and its size will be 26 and initial will be 0. Next we will traverse the string. For auto x in s, we need to increase the frequency of character. So we will do frequency at x minus a. So suppose if x is a, then we will get 0 index, and x is z, we will get 25 index. So, so this by doing this, we get the indexes corresponding to characters. We simply need to do plus plus. Now we got all the frequencies. We need to declare a set of, let's say, int, and let's call it scene. Now we will traverse this frequency int I equals 0, I less than 26, I plus plus. Now what we need to check, that while frequency at I is greater than 0, because if it becomes 0 we don't have to worry about this, and this particular frequency is not already seen. So we do scene dot find frequency at I not equals scene dot end. This checks if it is already present. That means if this frequency is present, what we need to do? We need to reduce the frequency at I and also increase our answer. So let's first declare it here, and answer equals 0. At the end, what we will do? We will simply add this frequency in our scene set. So scene dot insert frequency of I. And at the end, we will simply return answer. So what we have done here, we have declared a frequency. We have got all the frequencies of characters present in the string. Then we declare an answer and set, scene set. Now we are simply traversing the frequency array, and we are trying to calculate the unique frequencies. And until we are finding a unique frequency, we keep on reducing the frequency and increasing the answer. And at the end, we add this frequency in the scene set. And finally, we return the answer. Okay, sample test cases are passing. Let's start submit it. So it is getting accepted. Now let's analyze the time complexity of the solution. So here we are traversing the whole string, and if the length is n, we are doing a big of n operation. Then afterwards, this we know that the size of this set can get a maximum up to 26 because there are only lowercase characters present, and this whole for loop will traverse just for 26 times. And also this while loop can go a maximum of 26. So we can see that all these loops and while loops have a constant operation. So what finally you can see that the time complexity is big of n and the auxiliary space is big of 1 because 26 space is just a constant space, and it doesn't depend on the size of the string s. Even if the size of the string s becomes millions times greater, this size will not change. So in the space complexity or time complexity, we see by how much order the time or the space required is changing when we are increasing the size of our input. So here this doesn't depend on the size of the input. So we can say it's constant space. So time complexity will be big of n and the space complexity will be big of 1. And if you have watched this video till here, I would like you to please consider subscribing and like this video, comment your thoughts, and also you can comment what you want me to make more. So thank you and see you in the next video.